Good afternoon, and today we'll learn about square roots and close boundaries. These problems appear on SAT and maybe some numbers like 2 or 3. And the first one we're going to talk about square roots. So, what are square roots? Imagine you have a square or field and you know its area is 16. But how do you know its length? Well, we know that the formula for squares are length times length. So, yes, if the area is 16, then 4 times 4 is 16. And this is why in the multiplication table, we'll see that 2 times 2 is 4, and 5 times 5 is 25, and then 9 times 9 is 81. So, what do I mean by square root? Well, in math, square roots are this number, whereas the square one is this. So, if we have 4 times 4, it is 16, and 5 times 5 is 25. And you can see that, well, I'm just going to show it up to 14 because you don't have to memorize all of the squares, you just have to understand what is the square and what are square roots. So yes, this is the summary of multiplication, and we can convert it into square roots. So square roots are basically the inverse of square. For example, the square root of 9 is 3, the square root of 16 is 4, and the square root of 25 is 5, and so on and so on. This is table up to 16. So since 4 times 4 equal to 6, isn't it the same as negative 4 times negative 4, which is also 16? Well, no. In math, there's a thing called principal square root, which means that we only take the positive side. So, as you can see that minus 1 times minus 1 is actually 1. And still, we're going to take the positive because it is rule. So, it is not an axiom, it is a rule. So, basically, we agree that we should only take the positive part of the square root. And if we look at the graphic, which is allowed in decimals, this is slower than the y equal to x. So we know that the y equals to x is a line, and a line that passes through like here. So whereas a square root, it is going to be like an inverted parabola. So a parabola is something like this, and if you try to rotate it into 90 degrees, but you remove the right side, then you will get something like this, and something like this. Oh, I'm sorry, this is not right. This, and if you rotate it, you will get something like this. So yeah, this is square root. Now, why do we want to talk about square root? Because it appears in the SAT problem. So this is one of the fascinating problem. It says that square root of x minus 3 is equal to 3 minus square root of x. If x is solution, what is the value of this? I'm going to give you 1 minute to talk about this problem and try to solve it if you can. And I'm going to skip it because this is my teaching. So here's a step-by-step answer. The first one is, of course, we will write the equation. It's going to be square root of x minus 3 equal to 3 minus square root of x. And we're going to square. Why? Because square root, its inverse is square. So we're going to square it, and we will get x minus 3 equal to 9. I'm assuming that you know how to square, because in the previous lessons we talked about how to square a plus b. And a plus b squared is equal to a squared plus b squared plus 2 times ab. So this is 3 squared. As I said, this inverse of square root is square. So the square x and its square root is going to be x, and minus 2 times 3 times minus the square root is going to be this, and you can just remove x because you subtract both minus x, and you minus 9, or just move 9 to the left side. You're going to get this, and you will get that 2 is equal to square root of x, and of course you just need to square it, and the square root of 2 is 4, so you get that x equal to 4. But that's not the answer, because if you look at the question, what is the value of this? So you need to plug 4 into the square root of x minus 3. What you get is the square root of 4 minus 3 is 1. And what is the square root of 1? It's this one. Another fast trick is you can just try to use the multiple choice. So 1 is equal to square root of x minus 3, and you can just square that, so you get 1 equal to x minus 3, and you get that 4 is equal to x. So if you assume that x is equal to 1, and I'm sorry, the square root of x minus 3 equal to 1, and the x is 4, and you plug it into the equation, you'll get that this is 1, so 1 is equal to 3 minus the square root of 4 is 2, so 3 minus 2 is 1, so yeah, 1 is 1. That's, if you don't understand how to solve it, then you can just manually guessing the multiple choice. That's one of the tricks to skip a hard question. Before proceeding, are there any questions? I'm assuming there are not, because this is my teaching. Okay, so next we will talk about the SAT verbal, which is close boundaries. So what are close boundaries? In the previous lesson, we talked about the dependent clause and independent clause. So this is an apple. Of course, this is an independent clause because it has a subject and it has a verb, and this will have a subject, verb, and an object. So what about this though? Now the tricky part is that there is a modifier or conjunction even though, and this makes the left side part of this sentence a dependent on. Why? Because if I just say even though I love apples, it doesn't click, right? Because yeah, so what? What happens if you don't love apples? Well, even though I love apples, so you need a new clause to explain what's the previous clause. So for example, even though I love apples, I don't eat those. So those refers to the apples. So yeah, so even though I love apple is a dependent clause, and I don't eat those, which means I don't eat apple, is an independent clause. Why? Because as we talked in the previous lesson, I is the subject, don't is the verb, and those is the object. Moving on, this is similar, but this is what we talk about the but or the conjunction. I love apple, comma, but I dislike its color. So this is an independent clause. Why? Because it has subject, verb, and object. But this, yes, it has subject, verb, and object, but it has the word but. So it cannot stand on its own, because if I just say but I dislike its color, it doesn't refer to anything. Like, what do you dislike? So moving on. Sorry. So this is the fine-branch conjunction, which is what? So what are those? Well, this is just a conjunction that either use comma or not, depends on the type of the clause. So you don't have to memorize it because, well, it's simple, it's just for and not, but and so on. So how do we use the fine-branch conjunction here? Well, there are general rules for this, and the first one is that independent clause semicolon. So yeah, this is the semicolon independent clause. So you can use semicolon for this type of clause. For example, like this is an apple, I love apples. This is equivalent to the period. So basically, you can use semicolon and period or dot to form the sentence. And this, I'm sorry, it should be dot. There's a okay. Okay, let's move on. Basically, there's something wrong in the material, so I'm going to well, let's add it. So independent clause semicolon. This is not semicolon. I'm going to use dot here, period. So basically, independent clause, period, independent clause is equivalent to the semicolon one. So just assume this is just a period, dot, and this is, you remove this, dot, so basically this is an apple, period, I love apples. And the next one is, yes, this is the independent clause, the one we use fanboys. So if you want to use fanboys, it has to be in a dependent clause. So independent clause, and then you have fanboys, which is for and nor but, and dependent clause. So yes, this, for example, like this. This is an apple, and I love apples. And this is equivalent to the, this is an apple, dot or semicolon, I love apples. Now why this matters? Because in the example question we have in 1942, blah 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 blah. How do you answer this question? One way to answer the question is to complete the text with that convention of standard English. How do you do this? Well, so here, first one is you cut off the sentence that, or this paragraph that doesn't need to be analyzed. So you have to look at the last sentence. Wait, software will involve more than just blah 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 as a pure and computer programmer. However, will usher in the digital age. So what you need is, you can just, well, check manually what is this, this, and yeah, if you follow the rules like the previous one, then you'll know that this doesn't make any sense, because although it's not fanboys, it cannot stand on its own, because it makes the next sentence dependent clause. What about this? Well, if we just plug in, we'll involve more than just a question though as a pairing. There's no like something to stop or to punctuate what, or to separate the clause. So yeah, it cannot be C, it cannot be D. What about A? Well, there's a column here, but do we need column though? No. Why? Because more than just a question though, comma though as a pairing. No, you cannot use though and then column. So yeah, cannot A, cannot C, and then cannot D. So the answer must be B. Why? Because though here acts as a like a stop. So basically, Hopper Summer Carrier will involve more than just a question. And then, well, you can just substitute though as a period, and it's going to be period. And as a pioneering computer programmer, Hopper will help usher the digital age. So this is SA is something like conjunction. Pioneering computer programmer. This is the subject, Hopper is subject, and then usher the digital age. So this is the complementary. So yeah, that is the reason why B is the correct answer, and all of the answers are wrong except B. Is there any question? If not, then yeah, so we're going to review. So in math, we learn what is square root and how it's linked to square as it inverse. Whereas in English, we learned about fanboys and their relation to clause.